and they're about using the multiplicative inverse to help you solve equations. Multiplicative inverse sounds like kind of a mouthful. It's helpful for us to remember when we studied the properties of multiplication that the inverse property of multiplication says that if you multiply a number by its reciprocal, that's like the upside down version of a fraction, that your answer is 1. And that's what we're going to use in this section. First, let us review a little bit about what we know about fractions. If someone asked you to explain in your own words what the fraction 3/4 means, there's a couple different things you might do. You might draw 4 objects and circle 3 of them. 3/4 might mean 3 out of every 4 things. So if I told you 3/4 of the students in a class preferred chocolate over vanilla, then you would group the students into groups of 4, and 3 out of every 4 of them would prefer chocolate. You might also take something, maybe it's a whole pizza or a whole cake, and cut it into 4 equal parts. And then you would take 3 of those to show 3/4. Now we have to remind ourselves a little bit about adding and subtracting fractions. So if I asked you to do this problem, 1/2 plus 1/3, first let's draw a picture of what this problem looks like. And we're going to use the model of fractions where we take a whole and divide it into some parts. So in this first picture, I've taken a circle, I've divided it into 2 equal parts, that's the 2 in the denominator, and I've shaded one of them, that's the 1 in the numerator. So this green area represents 1/2. I'm going to add to that 1/3 of the same size circle. So what's shown in purple is what I get if I take that circle and divide it into 3 equal parts and shade one of them. So what I'm asking is, what fraction of a circle, if I were to add together the green and the purple, what fraction of the total circle would be shaded in? The answer might look something like this. All I've done is I've put the purple and the green slices together. But the question is, what fraction is that all together, the purple and the green together? Well, clearly it's not some number of halves, and it's not some number of thirds of the circle shaded. We have to figure out how to represent what is shaded in total by the green and the purple. So we're trying to answer the question, what fraction of the circle is this? Well, one thing I can do is I can take the same circle, and instead of having part of it divided into halves and part of it divided into thirds, I can take the whole thing and divide the whole thing into sixths. And I notice that the green and purple areas are the same as the red area that's shown there. And the red area pretty clearly looks like I divided the circle into 6 pieces and shaded 5 of them. So what we need to do is to find out what fraction of the circle is shaded. We need to divide the circle into equally sized wedges. The 1/2 and the 1/3 were not equally sized wedges. We needed to divide it into equal wedges until we could see how many wedges are shaded out of the total. So you can see that I can overlay the green and purple shading on the red shading. And you can see if I move back and forth through this, there's the green and the purple shading, and now I overlay the sort of red shading on top of it. You can see that both pictures have the same fraction of the circle shaded. I've just got it cut into pieces of different sizes. In order to do this, we need to find the least common denominator. So I had a fraction that was 1/3, and I know I can write that a lot of different ways. I can write it as 2/6, I can write it as 3/9, I can write it as 10/30. There's a lot of other equivalent fractions I could make. The same thing for 1/2. I can rewrite the fraction 1/2 as 2/4, 3/6, 4/8. There's a lot of different ways I can write 1/2. What I'd like to do is to rewrite both fractions, 1/3 and 1/2, in equivalent forms so that they have the same denominator. So we're shown in purple here, we show 1/3. How is that the same thing as 2/6? Well, if again I overlay that red slicing on top of this circle, I can see that 1/3 and 2/6 occupy the same amount of space in the circle. On the right, the green was the 1/2. When I overlaid the circle sliced into 6, I can see that 1/2 and 3/6 are the same thing. So adding 1/2 and 1/3 together is really the same as adding 2/6 and then 3/6 together for a total of 5/6. And you can see that the total fraction of the circle that's shaded is 5 out of the 6 wedges. The big idea when you have fractions and you are adding or subtracting them, you have to make a common denominator. So in the problem shown below, I have 2/5 plus 1/3. Those have a different denominator. I need to rewrite them as equivalent fractions. So 2/5, that's the same as 4/15. And 1/3, that's the same as 5/15. Now I know that if I add together 2/15 plus 5/15, 4/15 plus 5/15, I get a total of 9/15. I have to make a common denominator before I can add or subtract fractions together. Now, please pause this presentation while you work through the practice problems that are shown in your packet. When you're done, you can resume your notes. Next, we're going to look at multiplying fractions. If I asked you to do this problem, 1/2 times 1/3, that multiplication symbol, often we translate that into the word of. So 2 times 3 means 2 sets of 3. 1/2 times 1/3 means 1/2 of 1/3. So shown here in purple is 1/3 of a circle. And if I take 1/2 of that, it's like I cut it along that dotted line. The question is, how big is the wedge I get when I cut that purple wedge in half? Well, it looks like it's going to be 1/6 of the circle. How do I do that mathematically without drawing circles each time? Well, the big idea when you're multiplying fractions is that you multiply the numerators together, that's the numbers on top, and you multiply the denominators together. So if I asked you to multiply 2/3 times 3/4, on the top you would multiply 2 times 3, and on the bottom you would multiply 3 times 4. When you do that, 2 times 3 would give you 6 on the top, 3 times 4 would give you 12 on the bottom. So you would end up with 6/12. You could then go on and reduce 6/12. You could make that a simpler fraction. In simplest terms, 6/12 reduces to 1/2. Please pause this presentation while you practice multiplying these fractions together. In the second problem shown, there's 3 fractions that we're multiplying together. Remember what you learned about the associative property of multiplication that says when you're multiplying together 3 or more numbers, it doesn't matter which 2 you multiply together first. When you've got your answer to this, please resume your presentation. Next, what I'd like you to do is to do the multiplication problems shown below, their fraction multiplication, and reduce your answer to its simplest terms, to its lowest terms. So please pause this presentation while you work through these 4 example problems in your notes. What you should have noticed on the last page was that you ended up, when you multiply together a number, like 2/3, and its reciprocal, like 3/2, the answer you get reduces to 1. This is the inverse property of multiplication that we learned about very early on this year. But why bother with all of that? Well, the helpful thing about the multiplicative inverse is that you can use it to make a hard problem much easier. So here's a problem, 1/3 x plus 1/3 equals 4/3. If we're trying to solve this by doing things like adding the same thing to both sides and subtracting the same thing from both sides, we're going to have to do arithmetic that becomes more difficult simply because it has fractions in it. But what I can do is I can use the multiplicative inverse to turn this into an easier problem. Here's what I'd like you to put in your notes about how to do that. When you have a fraction as a coefficient, the coefficient means the number in front of the x, you can multiply both sides of that equation by the multiplicative inverse, that's the upside down of that coefficient, to make a much easier problem. So let's take the example below. 4/9 x equals negative 16. 4/9 is the coefficient in this case. It's the fraction that's in front of the x. If I multiply both sides of this equation by 9/4, that's the multiplicative inverse, I'm going to get a much easier problem. Let's see what this multiplying by the multiplicative inverse actually looks like in practice. So here's the problem from the previous slide. 4/9 x equals negative 16. I'm going to multiply both sides of this by the reciprocal, that is the multiplicative inverse of 4/9. So I'm going to multiply both sides of the equation by 9/4. That's 9/4. Remember that anytime I multiply both sides of an equation by the same thing, I don't change the balance of that equation. Now let's look at the left-hand side. 9/4 times 4/9. Well, any number times its multiplicative inverse is just 1. So what I have left on the left-hand side of this equation is 1x. And on the right, I still have negative 16 times 9/4. So I've already gotten x all by itself there. Now what I need to do is multiply negative 16 by 9/4. And to do this, I'm going to use the rules for multiplying fractions. It'll help me if I write negative 16 in its fraction form, which is negative 16/1. Now I can multiply my numerators together. Negative 16 times 9 goes on the top, that's negative 144. And 1 times 4 goes on the bottom, that's 4. When I simplify negative 144/4, I get negative 36. So by simply multiplying at the start of the problem by the multiplicative inverse, it turned my equation into one that's much easier to deal with. What I'd like you to do for these two problems, and they are shown in your packet, is first I would like you to identify the coefficient, that is, the number that's in front of the x. So in the first problem, your coefficient is 7/8. In the second, your coefficient is negative 2/3. Then I'd like you to write the reciprocal, the upside down, the multiplicative inverse of that coefficient. So in the first problem, it's going to be 8/7, and you continue on from there. What you're going to do then is you're going to multiply both sides of your equation by that multiplicative inverse.